With climate change, overfishing and plastic pollution soaking up all the attention in environmental nightmare land, sometimes it's nice to broaden our tastes a little. Welcome to the world of nutrient pollution. The chemical elements phosphorus and nitrogen are vital ingredients for life, the nutrients in nutrient pollution. They are so important, in fact, that their availability is a major limit on the growth of animals, plants and microbes. That is, add more into the mix and everything else being equal, you get more growth. For this reason, farmers apply large amounts of nitrogen and phosphorus to cropland in the form of fertiliser, allowing more food to be grown given the same area of land. For most of human history, fertilisers were mostly natural and consisted almost entirely of animal manure, which is rich in both nitrogen and phosphorus. There were, however, limits to the amount of growth that could be achieved through, spreading shit. These limits were, however, transcended in the early 20th century as synthetic fertilisers became widely available and exploded in popularity. These new fertilisers allowed much larger quantities of nitrogen to be fixed in soil than previously, and enormous quantities of phosphate fertiliser obtained through mining to be applied to cropland. This innovation greatly boosted crop yields around the world, tackling hunger and allowing for rapid population growth. And the impact of artificial fertilisers on humanity just cannot be overstated. Their use in agriculture has enabled us to support a much larger population than would have been possible otherwise. In 2015, just over 3.5 billion people were fed using nitrogen fertilisers, or just under half of the people alive on Earth. The catch is that the release of unnatural amounts of these substances into the environment, 22 million tonnes of phosphorus and 150 million tonnes of nitrogen to be precise, has a range of negative consequences, ranging from the costly to the potentially catastrophic. When released into bodies of water, excess nutrients can cause an overgrowth of algae known as an algal bloom. When the algae die, they consume huge amounts of oxygen which is dissolved in the water, effectively suffocating fish and other aquatic organisms in the affected area. This is known as eutrophication. The effects are so extreme that these areas are often referred to as dead zones. One rather sad estimate is that the global extent of these dead zones is now greater than that of the world's coral reefs, with one of the largest and most severe affecting the mouth of the Mississippi, where fertiliser runoff from several states all gathers in one place. Eutrophication directly threatens natural wonders such as the Great Barrier Reef, but it's not only nature that suffers. The impact on the economy can also be severe. Between 1970 and 1990, the fishing industry in the Black Sea lost an estimated $2 billion in revenue due to reduced catch, and the cost to other sectors such as tourism is also heavy. The risks to human health are potentially severe too, with the ingestion of nitrate polluted waters linked to the development of a condition called blue baby syndrome, which reduces the blood's capacity to carry oxygen. But perhaps most concerning is the long-term, broader effects of nutrient pollution on ecosystems, which we just can't accurately predict. Overloading the environment with nutrients is an extremely risky experiment. What we do know is that we are changing marine ecosystems in quite drastic ways, and possibly undermining the life support systems that allow humans to flourish. Governments around the world have been trying to reduce agricultural nutrient pollution for decades, and more recently these efforts have been stepped up with the introduction of laws regulating fertiliser use and practice. For example, Denmark managed to reduce nitrogen pollution by over 50% between 1990 and 2018 by supporting farmers to use fertiliser more efficiently, including placing restrictions on spreading at certain times of year. Improving management of agricultural pollution and introducing stricter environmental laws can play a part in reducing nutrient emissions. But is that enough? It's a start, but the elephant, or perhaps the cattle in the room here, is our diet. Roughly 3/4 of global crop production is currently used to feed grazing animals, and the global shift towards higher per capita meat consumption over the past half century is, unsurprisingly, one of the major factors driving up fertiliser use. An increasing global demand for meat is therefore likely to put significant additional pressure on the ecosystems that support us in our way of life. Moving to a plant-based diet, or at least reducing our meat consumption on the other hand, would allow us to feed the world with a fraction of current cropland. It is far and away the most effective step that somebody can take to reduce nutrient emissions and, for that matter, greenhouse gas emissions. So, if you've learned about a brand new environmental catastrophe today, don't worry. There is certainly at least some room for optimism. Whilst it's up to governments and multinationals to pick up the majority of the slack, which will be a common theme on this channel, there's at least one way that individuals can help to make a difference.